Welcome to the Neurostimulation Podcast. I'm Dr. Michael Passmore, Clinical Associate Professor in the Department of Psychiatry at the University of British Columbia in beautiful Vancouver, Canada. The Neurostimulation Podcast is all about exploring the fascinating world of neuroscience, clinical neurostimulation, interventional mental health, and general mental health and wellness. We consider the latest research breakthroughs, and most importantly, how that research is being translated into real-world treatments that can improve health and well-being. So whether you're a healthcare professional, a student, a researcher, or just someone who's curious about how our brains work and what we can do to help them work better, this podcast is for you. My mission is to make the science accessible, inspiring, and relevant to your life. This podcast is separate from my clinical and academic roles and is part of my personal effort to bring neuroscience education to the general public. So I would like to emphasize that the information shared in this podcast is for educational purposes only and is not intended as medical advice or a substitute for professional medical guidance. Always consult with your healthcare provider to discuss your specific health needs and treatment options. Today on the Neurostimulation Podcast, I'm joined by one of the leading voices in psychiatric neuromodulation. Dr. Noah Phillip is a professor of psychiatry at Brown University, section chief of psychiatric neuromodulation at the VA Providence, and a leader at the VA Center for Neurorestoration and Neurotechnology. His work sits right at the cutting edge, bringing together clinical psychiatry, neuroscience, and emerging technologies to better understand and treat conditions like depression and post-traumatic stress disorder, or PTSD. And so in today's episode, I'm really looking forward to the conversation with Dr. Phillip, where I'm hoping that we'll dive into a fascinating new multi-site study from his lab looking at transcranial magnetic stimulation, or TMS, for post-traumatic stress disorder, and specifically whether different protocols actually matter in real-world clinical outcomes. We'll also explore where the field is heading from accelerated TMS to focused ultrasound, and what a truly precision-based approach to neuromodulation might actually look like in the next decade. So Dr. Phillip, thanks so much for joining me. I'm really excited for this conversation. Welcome to the podcast.
Thank you so much for having me. I'm absolutely delighted to be here.
That's great. Yeah. You've built one of the leading neuromodulation programs in the VA. And so I'm just curious, maybe you can help us to understand how that came about and a little bit about your background and what got you to this point.
Yeah, so absolutely. So as you heard in the beginning, I'm one of the associate directors of this Center for Neurorestoration and Neurotechnology. Really some words that we can use to always win a good game of Scrabble. And so this is a group, and really this is a laboratory that I've been building for the better part of the last 15 years. And the goal is to design, develop, and deploy neuromodulation treatments, really focusing on non-pharmacologic neuroscience-based interventions that leverage what we know about physics and about the brain to come up with better treatments than what we have right now. And we've been pretty successful. This started really as just me back in around 2011 when we started things, when I moved over to the VA, and through a series of grants, awards, and development. And I recruited a large number of faculty and have grown the team. Everyone really with a shared purpose and a shared goal towards moving the field forward and helping our patients.
Yeah, amazing. Yeah, really. And I think it's really inspiring to build a program like that. And as you say, to have the vision to want to explore these technologies, because I think a lot of the psychiatrists and clinicians in mental health that I talk to, one of the things that is a common refrain, I know I've certainly lived this for many years, is the frustration with legacy treatment options. Medication, psychotherapy, sure, those are very valuable for a lot of people, but there are many people who have treatment-resistant conditions, treatment-resistant because those particular options leave them with persistent symptoms. And so the neuromodulation technologies are really exciting in a way that allows people a different option to be able to maybe even combine with these other modalities. So expanding the toolkit, so to speak.
One of the things I want to highlight something you just said and dive in, if you will, for a minute. It's not necessarily about neuromodulation, but I think it's a really important thing for the conversation for the listeners. And you use that term treatment resistant. And that's a phrase that we use often in psychiatry. And we use that to define or describe individuals who have not responded to a treatment. But the truth of the matter is, we don't know what that is. That doesn't have a definition aside from that they haven't responded to the thing that we've given them really arbitrarily. And we don't really know if people are in fact resistant to treatments because we don't know if we gave them the right treatment at the right time, right person. And that's the goal of precision psychiatry, right? To find a better way to do it. And it's actually my hope as we dive into this field more that this thing that we call treatment resistance, maybe we can understand it a little bit better and move away from a phrase that sort of describes really more of a lack of our understanding rather than a lack of what we can do with our treatments.
Yeah, thank you for highlighting that. I'm partway through Dr. Chris Aiken's book on difficult to treat depression, right? And so he promotes the use of those other different kinds of terms, difficult to treat, challenging to treat, because exactly as you say, it's part of, I think it's the metaphor that I sometimes use is that if you're following a recipe, it's great when the cake turns out the way that you expect it based on the recipe that you follow, but people aren't cakes, right? And so when you follow a recipe, that might be the recipe according to the DSM and or the latest treatment guidelines, there's going to be that significant minority of patients that don't respond, that don't get better. And so what we really need is an expanded toolbox, as you say, precision mental health, precision psychiatry. And so, thank you for bringing that to our attention right off the bat, because the words that we use are really important.
I think so. And I love it, right? Our patients' brains and their lives don't read the recipe. Yeah. And
totally.
That's the world we live in. Yeah.
Yeah. Absolutely. Well, how about if you don't mind, maybe can we talk a bit about your lab's paper there about what you found with the TMS and the different approaches with PTSD? That would be super interesting.
Yeah. Let me start with, if you will, the bottom line up front, which is when we're thinking about what treatment paradigm, what form of transcranial magnetic stimulation to give to someone who has post-traumatic stress, the answer really is whatever the device is that you have in front of you. And that's really the bottom line up front. And we'll build up into that and we'll get there in a bit. But before we get to there, what we need to think about is what's the frame of the question? So why would we care? And the reason we would care is there's a long line of papers, clinical work, and what have you that have examined what are different outcomes with transcranial magnetic stimulation for post-traumatic stress and different parameters where energy is put on different parts of the head, different settings, what have you. And there's always a question of what works the best or what do we hope might work the best. And that's really the framing of the question just to get us started.
Yeah, definitely. Again, it's just such a variety. Part of it is the complexity and the variety. I do a lot of old age mental health and it's just a little limitless, the complexity and the variety. And I think so similarly with conditions like PTSD, not to mention the complexity, the variety, the individual nature of the story that person brings, but then their particular trauma is unique to them, right, in many ways, right? So it's how to align those specific individual needs with these different treatment options. And so what was it that you found with this particular study that was leading to that conclusion around using the machine that's in front of the clinician as opposed to being fussy perhaps about what kind of approach or what kind of machine or ITBS or any of these other kinds of approaches that are being explored?
Yeah, so we had, over the years, we've done a number of different clinical trials using different machines, different settings, what have you. I believe we were the first to do a randomized controlled trial looking at theta burst stimulation for post-traumatic stress, among others, and lots of other people have been in the space in different settings. And one of the within all of this, there's a lot of discussion on what are the different devices that are around. And that comes down to an access question. So early days, several machines, couldn't do theta burst. So there's an issue with their capacitors, an issue with their electronics. And actually, while that's no longer an issue here in the States, If we think about other places that are resource poor, so this is a segue, I'm going to come back to it. One of the other things I've been doing over the last couple of years is teaching transcranial magnetic stimulation in Ukraine. And they, in those situations, don't have access to machines that are able to do the sorts of things that we might have in the States or in Canada or what have you. And trying to figure out what you could do in all the different environments to make sure that we can meet the needs of our patients is critically important. And if you'd asked me these sorts of questions about 10 years ago, I would have given you a different answer. I would have said, okay, so for post-traumatic stress, we should be stimulating with a low frequency on the right-hand side of the brain. And maybe for depressive symptoms, we should be simulating the higher frequency on the left-hand side of the brain. That was based on a series of studies, actually early PET work, that showed some asymmetry between the left and right sides of the brain in both of those illnesses, respectively. And the idea and the hope was to enhance activity or suppress activity according to what those early scans showed. Truth of the matter is, if you really go back and read some of these older studies and you dive into the supplements, the story is not quite as clear as we would like. And so moving forward, so we'd done a study here, a study there. Our colleagues had done different studies. And what we were seeing, though, was a common story that was starting to emerge, that really it always seemed to work. I think to my personal chagrin, maybe the things that I had come up with didn't seem to be working any better than anything else. And whenever you have these kinds of situations, then it's time to take a big step back and do a really good study and figure out what's the ground truth that might be underneath all of this. And that's really lays the foundation for what it is that we went and did.
Yeah, thanks for that. That's very helpful to get that background. And I'd like to circle back to hear more about your adventures in Ukraine. That's so inspiring. But before we leave the study, so I'll put a link to the study in the show notes for folks, and we'll flash a visual of this for viewers. But the study is called Effectiveness of Transcranial Magnetic Stimulation for Post-Traumatic Stress Disorder, a multi-site propensity-matched cohort study of treatment parameters. And that was published in the journal Brain Stimulation earlier this year. What I'm understanding then from the study basically is that there was a comparison. So this is a multi-site VA cohort of around 756 veterans, and there was a comparison of approaches with RTMS. The three approaches that were compared were the 10 hertz RTMS, ITBS, and deep TMS. Is that correct? Oh, yeah.
What we did was we tried to take advantage of a naturalistic application of the use of the stimulation. So we have a program across the U.S. through the Veterans Affairs system that allows large-scale deployment of this technology. And through, if you will, artifacts of time, different people have different devices, different settings, honestly, different comforts with different settings. And so what we did was we took a cohort of individuals, so 750 some odd, that had gotten stimulation over a large number of different sites, incredibly both geographically diverse and otherwise. Because we really wanted to do the sort of study that ultimately would be very challenging to do in any other environment, both in terms of the sample size and in terms of the approach. And so what we looked at, so it's naturalistic treatment across many different sites, of 35 or so, if my memory serves me correctly. And then what we did was we did propensity matching, which let me unpack a little bit here, which essentially, so we took individuals and it's a series of mathematical formula that essentially what we do is we are matching them as if they were coming into a randomized controlled trial and randomized based on things that we want to make sure that we are maybe not controlling for, but adjusting for. So things like age and sex and symptom severity, and then comparing the clinical outcomes and essentially doing a comparison against the two. And in this case, we're using 10 hertz as the reference. And the reason we're using 10 hertz as the reference is that's been around the longest. And so we felt that was a fair sort of common comparator. Intermittent theta burst has only been around since 2018. The deep TMS systems, depending on has been around a little bit longer than that, depends on what the access and availability is. And the goal here really was to query So it's a different frequency. So 10 hertz versus ITBS, both higher frequencies, but then both on the left side. And also compare that to the broader, very broad deep TMS application, which is really depolarizing most of the prefrontal cortex. And so what does that test, right? That allows us to test differences in frequencies, differences in placement of coil, and also the distribution of the induced electrical field, which is a common thing that we think is driving much of the effects of transcranial magnetic stimulation. So this, in essence, is creating a naturalistic experiment with a very large sample size. Also in people who typically don't respond quite as well to treatments in general, have a lot of real-world comorbidities in terms of medical and psychiatric comorbidities, and are generally quite sick, and then lining them up and comparing each group against each other.
Yeah, that's fantastic. I think there's so much value in these kinds of studies to be added into the mix with more typical sort of strictly randomized double-blind controlled trials and that, because there's something really significant to be said for this idea of experience. I'm not saying that this is strictly experience-based medicine, but to balance an experience-based naturalistic kind of study with the other more like hardcore evidence-based medicine types of studies, I think that balance is very valuable. And yeah, because as you say, I think that commonly people with PTSD, that I'm sure viewers and listeners know, who are clinicians and researchers, and even people themselves who are struggling with these disorders, they're complex disorders. There's lots of comorbidity. There's people are bringing, like I said before, their own unique stories to these situations. And yeah, this is fascinating that the study as a naturalistic study resulted in these really interesting findings. And so what I was noticing then was that there was consistency across the approaches. So the 10 hertz RTMS was the response rates were 63% for the 10 hertz RTMS, 65% for the intermittent theta burst stimulation, and then 78% for deep TMS, but non-inferiority across all protocols, basically.
Yeah, that's correct. Just before we dive in, I just want to highlight and underscore one other thing, which is, even though it's a naturalistic study, this is a nice hybrid in between a sort of sham-controlled, randomized controlled trials and an unblinded follow of just how people do over time. So it's a nice mix between the two that brings a little bit extra rigor into the naturalistic space, sets up a testable hypothesis. And right, so here we were looking at non-inferiority. And just as a reminder for listeners, what is that saying? It's saying that certainly one is not worse than the other. And essentially, it's not the same thing as saying that things are the same. That's equivalence testing. And actually, equivalence testing is the two-sided version of inferiority testing, and which we did both too. But essentially, to your point, right, what we find is when we look at the three different groups, that there is very clear, statistically significant non-inferiority across the three groups, and I would say a really good response rate across all of the above. And each of these are translating, just to unpack this a little bit more too, each of these is translating to about a 20-point reduction on the PTSD checklist for DSM-5. It's plus or minus on the different groups. And what does that mean? And that is something real and something really meaningful. That's not looking at a result and squinting at it, finding some statistical significance that is a little bit hard to interpret in the real world. A 20-point reduction on this rating scale is really enough for a non-clinician to look at a patient and say, this person is better. So yes, it's statistically significant in terms of the improvements and things like that, but it is very clinically meaningful. And it's well over the bar that we would consider to be a clinically meaningful change on that rating scale. And I think that's a really important point that I think we do as a field do a better job emphasizing the clinical significance as well as the statistical significance, but it's a big drop. And that's a really meaningful change for a lot of people in their lives, which is just great.
It's fantastic. Yeah, congratulations on that. And thanks again for walking us through that. I confess I'm a knuckle-dragging clinician, so I'm the kind of clinician that usually would just skip to the conclusion section of any journal article in the abstract. And even more so now, I'm outsourcing my critical appraisal to ChatGPT and other LLMs. So but yeah, no, that is a very helpful way of explaining the advantages of the way that the study was designed and executed. I think it's so fascinating. So yeah, so what I'm understanding is, as you're saying, a remission rate of up almost 50% across all groups. So 47 to 49%, which is phenomenal and really exciting just for all the people that need this kind of help, and people because PTSD is that kind of condition, right? It's debilitating, it's chronic. There's ripple effects in terms of families and all kinds of different challenges that people end up with. So it's no surprise that there's been exploration with these different kinds of treatment options, whether it's neuromodulation or psychedelic assisted psychotherapy, different kinds of approaches, right? Yeah, I think it's so interesting. Were you somewhat surprised by the outcomes that you found?
This was the direction I had hypothesized we were going. We had seen enough in enough different spaces that I didn't really expect that we're going to see a large amount of meaningful difference. The other thing we saw in this, by the way, was also non-inferiority across the board in terms of depression outcomes, which I think actually, and maybe one of your future commentators will tell me I'm wrong about this, I think it's also the first time that people have shown non-inferiority, not just with theta burst and 10 hertz, which has been shown, but also with deep TMS, theta burst, and standard, if you will, TMS. It's funny, I don't use the abbreviation RTMS. The reason I don't is I'm from Boston originally, and every once in a while, the R starts sounding a little funny, and people are wondering what the heck I'm actually speaking about. But it's ATMS, right? But I got to be a little bit careful with that. But to your question, right? So this was a hunch. We had set this really up to test at least non-inferiority, if not equivalence. And this was generally where I thought we were going to be seeing it. And the other thing that you'll notice if you take a look at the paper is that the curves, so the changes over time, are also look very similar. So we know that not just the outcomes at the end of treatment are the same, but really people's trajectory of improvement is comparable across the board. And so that's also a really important thing when we talk to patients and educate them about what they can expect over the trajectory of their treatment and resultant effects on their illness.
Yeah, it's fascinating. It's really exciting for people who are just looking for different treatment options. And I'm curious now, I'm understanding that your lab focuses on precision neuromodulation. And before we started, we had a little bit of an offline conversation about some other studies that your lab has been working on. And maybe you can walk us through a little bit about other projects that your lab's involved with now and how that might actually start to translate into treatments that can be implemented in practice.
Yeah, we could almost this is a bit of a jumping off point, because what we found in this study really is not precision, right? What we found is the 3 different approaches actually doing the same thing, and yet, really to turn that argument on its head, what all of these are doing are delivering large amounts of energy to pathologically affected parts of the brain and fundamentally disrupting homeostatic pathology that we call PTSD or we call depression or what have you. And I suspect that the common theme across all these protocols is as long as the energy is getting in, that's what matters. And I think what it also does is it sets a really important floor. So we know now that we can get a 20-point reduction on PTSD symptoms with these different forms of transcranial magnetic stimulation, and yet we need to do better. And so the closest thing, if you will, to this study is our work developing accelerated TMS for post-traumatic stress, as well as depression, but really primarily focus on post-traumatic stress. And there, what we're doing is we are delivering large amounts of stimulation in a short period of time. In this case, we're using a protocol that we in the system developed during COVID, where we deliver stimulation 5 times a day for 5 days. And what we can do, we published, I'm going to call it a case series. We published a case series of about 120 some odd individuals earlier this year or late last year, showing that we could get in 1 week actually a little bit larger than 20-point reduction on that same rating scale. I think that has to do with the sample size. I suspect once we start studying larger amounts of people, it's going to look closer to 20 points. But we can at least do that in a short period of time. So that's great. And that will help reduce the access and barriers to care, which is very important. Because precision, and we're going to get to the neuroscience in a sec, because that's really what I love, but precision is also about meeting people where they're at, right? It's the right person, right place, right time. And that includes people's lives. And many people don't have the capability, resources, wherewithal to come to a clinic once a day for 6 weeks. Elder care, child care, life, illness, what have you. And I think that we've got a great option with transcranial magnetic stimulation as it exists right now. But in order for it to do the good that we need it to do, we do need to change our model. And so part of what we've started thinking about incorporating with precision is also the person's life and making sure that it matches what they need what they can do. So that's one side. What you and I spoke about briefly beforehand were some of the other really much higher neuroscience-based precision technologies or different approaches that we've been using to what we hope will advance the field of brain stimulation for post-traumatic stress and all the things that come with it. The first of which that's worth talking about is trying to bring precision to the context of how we stimulate people. And so this was published in JAMA Psychiatry a year and a half ago at this point, where we took veterans with combat-related PTSD, combat exposures related PTSD, and we gave them a combination of transcranial direct current stimulation plus an exposure done in virtual reality. So we had a lot of a high degree of control of the virtual reality space in terms of what people were being exposed to over time. And the difference there is this is a low amount of electrical stimulation, much, much lower than what we do in transcranial magnetic stimulation. And if we did that 3 times a week, really for 2 weeks, again, that's much less of a treatment burden. We could meaningfully reduce symptoms, and we showed a very strong active versus sham effect in that study.
Yeah, that's incredible. It's a great example of how combining tools from this expanding toolkit, these are not necessarily competing treatments, these are often complementary treatments. And I think it was so interesting how before describing that particular study, you mentioned considerations about the commonalities. So what we can infer about the perhaps pathophysiology based on commonalities of treatment approaches with non-inferiority at least, or similar effectiveness. And it makes me think about studies, more recent headline-catching studies that show similarities, for example, with respect to adenosine being important for ketamine improvement as well as ECT improvement in depression. And so it's really interesting to think about what are these commonalities and what does that teach us about how we think about these disorders and the pathophysiologies in the first place. But yeah, it's super interesting.
And it also reminds us that we have a lot of ways that we can help if we think carefully and know a little bit more about the brain, right? That there's actually an enormous number of things that we can do. And I think to your comment in the beginning about being a clinician and being challenged by the availability really of legacy treatments, I'm also a clinician and I struggle with the same things. And it's when we take a little bit of a step back and look at the things that we can do, the neuroscience gives us a tremendous amount of hope. It gives us a lot of new options. And so even if everything that we do right now that we have available today might not work for someone, which can still happen, it doesn't mean that the next thing that we come up with isn't going to work. And we really can start coming up with eventually things that will suit each person depending upon their own biology. We're not there yet. I really wish we were, but it's really that's the mission of my group, and also I would say a shared mission across many people in the field. One other thing I just want to say about the transcranial direct current stimulation, and this actually gets to some questions around access and use. And the neat thing about it is essentially the stimulation that we give there is what you can get out of a 9-volt battery. And we set it up where there's an anode where the electricity goes into the brain and a cathode where electricity comes out of the brain, and that creates a very simple circuit that delivers just a tiny little bit of electricity into the brain. And then what we can do is we can take very complicated electric field modeling, figure out where to put that anode and that cathode. So we're getting the brain regions that we want to, and that does bring in a whole lot. And we've actually shown that even when you put an anode in the front of the head and a cathode in the back of the head, there are current gradients that are going through core areas involved in post-traumatic stress, like the insula, like the hippocampus, like the amygdala, and we can engage those very deep brain targets, although with no spatial specificity. So we're really just bathing the brain in an electrical gradient. The nice thing about that is that when we're doing that, essentially we are biasing neurons in a direction that we want them to go. And so that's when adding in a behavioral component, we use virtual reality. You could do therapy too, but what it allows people to do is engage more fully, or perhaps get that behavioral intervention to depolarize the neurons that we want to train to depolarize. And that helps the brain to move into a more healthy state. We really do need these neurons in, for example, the medial prefrontal cortex to be reliably working when in fact they're not, in illnesses like post-traumatic stress and many others. The neat thing about this, and which you bring up also, is that many of the things that we're doing here are not diagnosis specific. They're really shared features across many illnesses.
Yeah, it's really interesting. I think tDCS is very interesting. Transcranial direct current stimulation. I have a handful of devices that I use clinically, and it's been really helpful. I think, again, talking about accessibility, remote MD supervised home-based use is really an advantage for a lot of people. Yeah, it's just more accessible. It's less of a cost barrier. But I also think that it's, considering all of these different approaches and what you're describing, again, it's this definition of precision neuromodulation as meeting the person where they're at. And so I wonder also, in terms of maybe even, I had a hat tip to AI just now, and so maybe even using the LLMs to help us to generate more specific kinds of approaches towards individuals based on their particular family history, personal history, symptom complex, as you say, biomarkers, anything that could be plugged in. And then you could get perhaps some output around, okay, likely to respond to this, less likely to respond to that, so that people are people and their clinicians are not as likely to be going down wild goose chases with treatments that are unlikely to work, that we can give people more of a map around what treatments are likely to work, or what combination of treatments are likely to work, and what out of those, what fits best with their particular lifestyle these days, or what kind of challenges they're facing.
Yeah, I'm very excited about how we're going to be able to use AI in this space in a number of ways. I think there are some opportunities for particularly synthesis across many different levels of analysis. I think there are opportunities here for people to essentially have a personalized living medical record that is a learning medical record that they can have with them at all times in ways that we don't quite have yet, but it's not that hard to imagine that. And the challenge, this is a separate conversation, the challenges, of course, will be related to privacy and things in that space. And unfortunately, we don't have necessarily a great track record of that kind of stuff. And we really do, that's part of what we got to figure out in this. And also, there is, I think, a very exciting future in using different kinds of AI, particularly facial decoding, speech decoding, to help us understand when people actually are starting to respond to treatment. We have some stuff we're launching in the lab. We and many others, we're not unique in that. But I do think there's a tremendous potential for us to be leveraging these tools for some real good. And in the near term, I don't think this is not a far away thing either.
Yeah, it's super exciting. And speaking of leveraging for real good, maybe we can talk a bit about your experience delivering this kind of education and technology to help people in Ukraine. That's so interesting.
Yeah, no, absolutely. And then I think if we have time, we get into super precision, which will be focus ultrasound sort of stuff. But the Ukraine. So I've been to Ukraine twice now in the last couple of years. We were going to go back recently. That's the current situation has been a little bit challenging and complicated. And let me actually start off by saying that I don't have any connection to the people in Ukraine aside from understanding what has happened through media outlets and what have you. And so I was giving a grand rounds some time ago, and in response to that, someone basically cold called me and said, "You seem to know something about TMS for post-traumatic stress. We have some colleagues in Ukraine that were gifted some devices that they're not entirely sure how to use them or how to optimize them. And would you help?" And it was a profoundly moving outreach. And the first thing I did actually was I went home and I asked my wife what she thought about that. And also asked my kids. And I made sure that everybody in the family had a veto. And if anyone felt overly concerned about it, I wasn't going to do it. But one of the things, and sometimes kids really delight you, what my kid said was, you know something about this, and you have an opportunity to do some good. And so I set up a call with it's the Unbroken group. It's in Lviv, and it's essentially a very large rehabilitation hospital or rehabilitation group. Its primary focus is on psychiatric and medical, and they do a whole bunch of different things. And they had been gifted some devices early in the war that were not well suited to clinical use. And we're using it in different ways. And they were hoping that I could come over and help them out and help figure out how to use them.
Yeah, very cool. Yeah, that's fantastic. Yeah, this is part of it as well, is that because the technology's been around for a few decades now, right? So as the devices, it's just obvious now that these technologies can help so many people. And so, as you say, it's just a matter of getting the devices into as many hands of as many people to use them as possible all around the world, and then getting people the training. But it's so exciting. I can just think back to a little over a year ago at the brain stimulation conference in Kobe, Japan, and just seeing how there's just this explosion of research and interest in all these different technologies like transcranial focused ultrasound that you touched on just now. So maybe you can walk us through a little bit about what your lab is involved with respect to this particular technology.
Yeah, so we have just wrapped up recruitment in all of our human subjects procedures. We're doing a first in human study of low intensity focused ultrasound to the amygdala in people who have depression and anxiety and all the things that come along with it. So because it's a first in human study, so it's funded by the National Institutes of Mental Health, and it's overseen by the U.S. Food and Drug Administration. So whenever we're taking something that is completely experimental, like focus ultrasound, we make sure that the FDA is the one that allows us to put an experimental device in someone's head. And focus ultrasound is very different than the other things that we've talked about here. So transcranial magnetic stimulation is magnetic. Transcranial direct current stimulation is electrical, and this is acoustic. This is mechanical. So it's an entirely different set of physics. And so in transcranial magnetic stimulation, we have a reasonable degree of focality. When we put a coil over someone's dorsolateral prefrontal cortex, we're getting a fist-sized field of what it is that we're delivering. It's not a laser. It's not all that focal, but it's reasonably focal. And it really lives at the surface of the cortex. Transcranial direct current stimulation goes all through the brain, but it is completely unfocal. And in focus ultrasound, I like to think, brings together the best aspects of both, in that it can get deep into the brain, at least we hypothesize that it can, get deep into the brain and with a high degree of focality. And so for the first time, we can start to think about directly and non-invasively modulating deep brain areas that we are aware of in terms of their impact in depression, anxiety, PTSD, any psychiatric illness. And really, the hope is that this can be a non-invasive form of deep brain stimulation.
Yeah, it's fascinating. It's fascinating also, just now when we were talking about perhaps extracting unexpected, more synthesis type conclusions from study results, like commonalities of effect and what that might tell us about pathophysiology, even more so when we're talking about differences in how the actual biophysics are impacting on different brain structures. So this idea about how acoustic energy and mechanical energy can actually change neural function and neural networks, that's fascinating too, isn't it? It almost challenges the idea of what, obviously, the neurotransmitter hypothesis of consciousness is. There's a reason why it's there, and but I'm guilty of going down rabbit holes into alternative theories of consciousness as well. And so this kind of thing makes me think about maybe some of these little kind of out there theories of consciousness. There's something to be said there. It's one of those philosophical questions to a large extent.
There is, maybe we can put this in the show notes. There's a theory of microtubule resonance underlying consciousness. And so who knows, which I think is great.
Yeah, I think maybe I'll definitely put links to the show notes, but with a significant caveat is these are outside of the box theories for sure. But I've heard a lot
very
about
very accurate statement.
Yeah, Dr. Hamroth, hyperbolic, I'll dare say, claims about ultrasound and treatments for Alzheimer's and stuff. But anyways, I think it's important to have outside of the box approaches, right? Without maybe broadcasting promises overly. We'll put it that way, perhaps.
And that's why we do very careful first-in-human studies with a lot of oversight from a lot of agencies, because we know that ultrasound, out-of-the-box hypotheses aside, we know that ultrasound can damage the brain. Folks right now across the world can go to tertiary academic medical centers and get ablative focused ultrasound for their tremor. It's a proven treatment. It's available. So it's FDA cleared in the States, available across the world. And it's very effective. And in that sense, what it's doing is it's taking large amounts of ultrasound, focusing them to a single point in the brain and inducing coagulative necrosis, better known as burning, and putting a hole. And very effective for tremor, but it's not something that we want to have happen by accident. And the other thing I'll say is that when we think about electromagnetic, so some of the laws of physics in the electromagnetic spectrum, so Faraday's law, Ampere's law, those are, and I'm going to get some pushback for saying this, but I'll go there anyway. Those are simple laws of physics. When we start thinking about wave equations, those are much more complicated. And there are a lot of ways that things can go wrong in ways that are nonlinear and not expected and can go wrong very fast. And we've already seen this. So there's one case report of a serious adverse event of using not low intensity focused ultrasound, I'll call it a medium intensity focused ultrasound, in a study of substance use disorders, inducing what is a cavitation event. So essentially a bubble induction and collapse in someone's subcortical areas, so in their nucleus accumbens. And that was reported last fall, and there's been a lot of discussion around that. So this is a technology that can hurt people. I think it's really important to understand that. And so finding what hopeful therapeutic uses is great, but the first thing that we have to do is we really have to drill down for safety and things in that space. And so in this study, so we have a number of people come in, we give them focused ultrasound to their amygdala. And in order to get to that point, we ask lots of questions, lots of assessments, lots of brain scans. We get CAT scans because what we need to understand is the structure of their skull, which is not something we have to do in any other sort of area of brain stimulation. Because every time the skull is dense, and so sound, the speed of sound, sound will accelerate as it goes through more dense media. And so we have to be really careful about what the skull is doing. And then after we do our ultrasound, we do essentially a stat MRI scan immediately thereafter, at 24 hours after, and 1 week after, as we do a number of other clinical things. So we're really very careful and thoughtful about safety.
Yeah, for sure. 100%. Yeah. And I guess that's the key with any emerging technology, is establishing the safety first and then going from there. But yeah, it's exciting to think about a non-invasive option that can target deep brain structures for sure.
We've seen now in the last, actually, I think week or two, we've seen 2 studies in healthy individuals using focused ultrasound, low intensity focused ultrasound. So that's amount of energy that you can typically get out of a diagnostic ultrasound. 2 different studies that have shown that we can non-invasively modulate the amygdala in healthy people. And that's great. And nothing bad happened. And it gave us some very important insights into how the amygdala functions. And so actually, I'm really excited. We had planned this, but I'm excited in the context of the data that's going to come out from our group where we're going to describe the not just clinical outcomes from this, but also the various different neuroscience outcomes. So we're going to describe how ultrasound changes brain perfusion, brain activity, and things in that space. And we did, and the other thing I'll say is, and the reason I'm not going into the details in too much is it's not yet peer reviewed, and I really don't want to get ahead of the findings. But one of the things that I do feel comfortable saying is that we had one person get worse from a psychiatric perspective. There was no injury. And so we had one person whose symptoms definitely got worse, and they got worse within about 24 hours of getting ultrasound. And we have also seen that in some of our colleagues' studies of focus ultrasound. So as we hope all these things can get people better, we have to also make sure we have a structure by which we can observe and capture when things don't go as planned. I'm sounding a little bit negative about this. I'm actually extremely excited about the field, but I feel I take the do no harm about what we do just so seriously.
Absolutely. Yeah. And I think that's so valuable. And I really appreciate that. I respect that. I think part of it is that it, as you say, it helps to clarify the map of where we're referring to in terms of the map of what treatment options that hopefully we can review with clients and patients, reviewing the potential for side effects as well as the potential for benefits, right? And not over-promising. And yeah, because anytime that there's a sort of a hyperbole again around miracle cures and what have you, there's always some reason to be somewhat skeptical about that kind of promise that's perhaps not realistic either.
Yep. And I have certainly started to see some offerings of ultrasound from medical spa situations, and that's really dangerous. That's just really dangerous. And the hyperbole doesn't help anybody. Right. And the nice thing about being an academic and doing this is we take our time, we do it slowly, we do it thoughtfully, and we figure what works and what doesn't, and we lay it all out there, which is I'm grateful and I am mindful of the blessings inherent of the ability to be able to do that kind of stuff as well.
Yeah, it's fantastic. It really is inspiring. So yeah, really just want to thank you so much and congratulations to you and your team and your lab there. Maybe before we wrap up, what would be I suppose the prospect that excites you the most about the next 5 to 10 years in this field? Do you think, is it FUS, TFUS?
I do think there's an enormous promise in focus ultrasound. I think 5-year window might be too optimistic. I think I do think there are some key challenges that we have not yet fixed, primarily how do we get the energy through the skull safely and things like that. That all said, the prospect of non-invasive deep brain stimulation, the prospect of being able to do that and with a technology that can travel, that can go, my wife is a veterinarian. And so they have portable ultrasound devices they put on their belts. And that's the same amount of energy that we're using. So we're talking about deep brain stimulation that can go where it needs to go. And that makes me truly excited.
Yeah, what a great way to end off a positive, optimistic message, trying to get these helpful, cutting-edge therapeutic tools into the hands of clinicians to treat clients and patients where they're at, meeting people where they're at, in a way of personalizing treatment, expanding the therapeutic toolbox to help get people better as soon as possible. Dr. Noah Philip, this was an incredibly rich and clinically meaningful conversation. What I think stands out most from your work and your lab's work is this idea that neuromodulation is moving beyond rigid protocols and towards something much more flexible, personalized, and scalable, as we're discussing. And so these studies are really challenging us, I think, to rethink how we might deliver treatment options like TMS, not as a one-size-fits-all protocol or a miracle cure, but as a tool that, just as an artisan might use a tool to really refine the approach to creating a work of art, that we're adapting the treatment based on the client and patient that's sitting in front of us. So with emerging technologies like accelerated TMS and focused ultrasound, it feels to me like we're just at the beginning of what's possible. So thank you again for joining us. It was just such a great conversation.
I'm absolutely delighted to be here, and thank you so much for this invitation.
Yeah. And speaking of Boston, you mentioned Boston earlier and being from there. I'm looking forward to being in Boston in June for the TMS conference there. So maybe I'll
see you there.
Okay,
yeah.
Fantastic.
Yeah.
All righty. Take care.
Good. All right. It's a pleasure. Have a good one.
Thanks, Noah.
Bye.
Appreciate it. Cheers. Okay. Bye.
Bye-bye.
Dr. Noah Phillip, this was an incredibly rich and clinically meaningful conversation. What I think stands out most from your work is this idea that neuromodulation is moving beyond rigid protocols and towards something much more flexible, personalized, and scalable. Your study really challenges us to rethink how we deliver TMS, not necessarily as a one-size-fits-all protocol, but more as a tool that we can adapt based on the patient that's sitting right in front of us. And with emerging technologies like accelerated TMS and focused transcranial ultrasound, it feels like we're just at the beginning of what's actually possible. Thank you so much for joining us today on the Neurostimulation Podcast. I hope that you enjoyed this conversation into the fascinating field of TMS and PTSD as much as I did. Thank you so much for joining us today on the Neurostimulation Podcast. I hope that you enjoyed this fascinating conversation about cutting-edge neuroscience and neurostimulation as much as I did. If you found today's episode interesting, don't forget to like and subscribe to the podcast. It really is the best way to make sure that you never miss an episode, and it also helps us to reach more curious minds like yours. If you think that today's episode might resonate with a friend, a family member, or a colleague, please share it with them. This kind of knowledge really is better when it's shared, and you never know who might find this information helpful or inspiring. For more details about Dr. Phillip's lab's work and the particular study that we discussed today, as well as the technology and other relevant content, please do check out the links in the show notes below. You'll find everything that you need to dive deeper into the topic. And I would love to hear your thoughts, so please do join the conversation in the comment section or reach out on social media. Your questions, comments, ideas, and feedback really do make this podcast better. Finally, don't forget to tune into the next episode. It's going to be another exciting journey into the cutting edge of neuroscience, clinical neurostimulation, interventional mental health, and general mental health and wellness. So thanks again for listening. I really appreciate your time, your interest, and your attention. Take care, stay curious, and I'll see you next time on the Neurostimulation Podcast.